Okay, so welcome to week 8. It's just been pretty amazing. Like I've just kind of been going over like everything we've done, and we've gone pretty far from the beginning. So congratulations to all of you for kind of progressing. So I just want to start out with some announcements, and then we have some presentations, and I really do want to go over muddiest points today because I think there is a lot of confusion about functions and Purrr. So I want to give you an opportunity to ask questions. And again, I would say that like what we're doing with Purrr is pretty advanced. So I don't think you should feel dumb because this is like really, this is functional programming was not something I learned until about, I don't know, about 3 or 4 years ago. And I've been using R for a long time. And it took me a long time to really wrap my head around it. So again, kudos for you for taking a stab at it. Okay, so just in terms of announcements, the midterm has been returned. So there was a request to see all of the other projects of the midterms. So I've put them up on this website here, and I'm going to paste this link into chat. And I apologize about the kind of boring titles. I was kind of doing this in a hurry. But you can see that everyone's, I think I'm missing a couple projects up here, and I will get them up as soon as possible. So if your project is missing, just please let me know in an email, and I will make sure to get it up. So these are all kind of links. There are lots of really, and you can see like there's a lot of different data sets that you all looked at. And it's really pretty cool. And again, if you want me to take your project down, you don't want to share it, please let me know and I will take it down, because I don't want anyone to feel like like feel any self-consciousness about this. Already one person let me know, so don't feel like you're alone in that either. Yeah, so I mean, there's lots of this was basic. There's no special order to this. I want to emphasize this was like literally the order in which like the order of the files in my directory. So it's not any, like the order is not indicative of anything. So just keep that in mind. So I don't want to single out anyone, but like so it's now available for you to browse and check out. So like I said, midterms have been returned, except for one person. I'm just catching up on that. And I thought everyone did really well. And I think like all of these documents are kind of testament to like, how far you all have come. So you should all be really proud of yourselves. Like I thought, it was really neat to see you all trying to tackle different data sets. Any questions about the midterm projects or anything? Yeah, again, I mean, it's nice to see what everyone else was working on. And, I think hopefully, the function of the week project has kind of emphasized that like, you can learn from other people and you can teach other people just from where you are. So like I said, you all should be proud of yourselves. Okay, so I do want to go over muddy points. So let's go over muddy points, and then we can go, we can have presentations. So a lot of the feedback I got was that Purrr was very confusing. So I'm hearing your feedback. So the class was pretty muddy for some of you. writing, and there's also like, there's still a lot of confusions about writing functions. So I want to kind of open it up. Like, do you want me to kind of go over functions again? And kind of the basics? Is there something specific you want me to cover in terms of functions? And you don't have to say it out loud. You can just send it to me in a private message on chat. And my other question was, did the homework help, or was it just more confusing? Okay. Okay. We'll be, there was a request last time for me to show one of my projects, and I have it. It's just that I was using a slightly different method than Purrr, but I was going to adapt it. I didn't have time to do it. I will have a sample of that. So yes, so if there's any, are there any kind of specific questions um, about about the homework or anything? And this is a good time to ask. Okay. So if you're still confused, again, I want you to reach out. I want you to, either come to office hours or make an appointment with me. I think, just like talking for a few minutes, I think we can clarify a lot of things, because I don't want to see anyone struggling with this. Because like I said, this is not trivial. Like, what Purrr is like functional programming, and this is, again, it takes some time to kind of get used to, but kind of the more you kind of play with it, the more you'll get familiar with it. So just know that the fog is going to lift eventually. So again, if you're having any issues, do reach out and make a time to meet with Eric or me. So yes, another muddy point was dot notation. So we will stay tuned during class. So here, this was just a request to see midterms. And like I said, this is now available. I'm just going to paste it in chat again for anyone who just kind of came in. So this is a link to the midterm projects. This was a really nice comment. One person said, I thought I'm not going to understand any of this, but they felt really comfortable with everything at the end. So anyways, someone asked, there is a function that showed us how to arrange plots in the RMD by saving them as objects and ordering them within the function. So that was Becky's presentation on patchwork. So it is right here. So that's I'm trying to get everybody's functions up and running, but some of you use different data sets. So I'm trying to figure out how to get the HTML files by themselves, because I've just been knitting all of the documents. So I may reach out to some of you if I'm having issues with that, so I can make sure to get your function on the web page. So yeah, again, so that cool package is called Patchwork. And Becky did a great job presenting it and kind of what you can do with it. Any other questions or concerns? Okay, so why don't we have presentations now? So I'm going to stop sharing. If I remember how to do that. And so I have on the list today, I have Sarah, Claire, Stephanie, and Martin. And if any of you are not ready, just send me a private message and we'll just kind of go down the list. So Sarah, would you like to go first?
Absolutely. I'm going to share my screen.
Okay, go for it.
It says host disabled
Oh,
participant
I'm
screen sharing.
sorry.
You're fine.
I need to change that default because most of the time I don't want to control that. Okay, you should be able to do it now.
Awesome. Hi and good afternoon. Today I'll discuss about the representation of overlap data using GeoMjitter. This function is used for discrete data sets. So in here, you can see the comparison of the representation of the data with the function and without the function. As you can see, we have a lot of overlap data points that are on top of each other. And on the left side, you can see the used function, and you can see the distribution of the data better than this. So in here, we have the Titanic data set, which has the fate of the passenger of the oceanic liner Titanic on it. And on the y-axis, we can see the fare, which is the money that the passenger paid at the time. By looking at this data set, we can, by looking at this plot without the function, we cannot get a lot of results from it by just visually looking at it. So the only thing that we can say is that the range of this data is from $2 to $512, but nothing more. So in here we have 549 people who didn't survive, which is number 0, and 342 people with that actually survived. But by only looking at this without the GeoMjitter function, we cannot really say we have this many of the people in here because, as I said, we have so many data points overlapped on top of each other. So GeoMjitter has some arguments that can help us to even better visualize the distribution of the data points. So we can make our points somewhat transparent by adding alpha argument to the GeoMjitter function, as you can see in here. So the darker the points, the frequency of the points on those parts are more. So as you can see, from the people who didn't survive, you can see that those people, a lot of those people paid $8 or less in here. So we can say that people who paid $8 or less mostly didn't survive. GeoMjitter function also has another argument, which is width. We can change the width of the function, which this one is 0.5, this one is 0.2. We can see the distribution of the data better with this.
Yeah. So Sarah, quick question.
Go ahead.
Can you go back? So if you did you basically overlay the two geoms on top of each other? So it's geom point plus geom jitter here?
Yes, it's geom point plus,
okay.
Yeah.
Yeah, I just wanted to clarify that because you see that middle bit through it, so.
Yes, I wanted to show that this GeoMjitter function actually adds some shifts to each point. So in that way, we can better visualize this. And we can see that shifting these points does not change our data because, as we can see, like in here, it's a categorized data. I wanted to show this. Also, we can even better visualize the data by adding a geom box plot to the GeoMjitter function. So in here, we can see the median of the passengers who survived is a lot more than the median of the passengers who did not survive. So actually, money played a role in surviving the passengers. So is it helpful? To answer these questions, I compared the plot resulted from the GeoMjitter function with histograms and bar plots. For example, as you can see in this bar plot, we can only get, for example, 1 to 2 numbers, and we cannot get the results that we visually got from this plot. So in order, in our case in here, it was more informative to use GeoMjitter function. I also wanted to show you that we can show two kind of discrete data variables by using MPG dataset. So in here, we have a city miles per gallon, highway miles per gallon. Both of them are discrete data. And we can see on the right plot that when a geometer function is used, it's better shown the distribution of the data. So in conclusion, using GeoMJITter is great to visualize distribution of overlap discrete data points. And it's even better when we use the alpha banding and width arguments. And with that, I would be happy to take any questions and comments that you might have.
Yeah, any questions for Sarah? And sorry,
So I have a comment actually.
Sure.
Or question, yeah, more of a comment. Kind of like on the point that you made, Ted, about like the points and the jitter, like you had the jam point and jam jitter. Because like I was using this jitter function once, and I noticed that there were two sets. Let's see. Yeah, I guess maybe the next slide actually will make it. Yeah. So on the left plot, you still see the like in the very center of each, like where the 1 and the 0 are. So there's actually two sets of your data here.
Yep.
So I just want to make that point because I did this, like I did GM point and GM jitter, but GM jitter actually kind of does the points and moves them around.
Yeah.
So because for me, I was like, why are there like double the number of subjects in my data?
Yeah.
And I couldn't figure out why, and I thought I did like a horrible duplication of my data, but it's because there was a GM point and GM jitter,
Yep.
So you only need one.
Thank you, Eric.
Yeah, I just want to make that point because it bit me in the butt. So.
Yep. Any other questions about GeoMJITter? I will say you have to be really careful with the width parameter, especially when you're plotting scatter plot data, just because it can introduce it introduces noise that may not actually be in the data, and it can be a little misleading. But I think definitely for visualizing kind of these discrete distributions, it's extremely helpful. It seems to be a little more accepted than, has anyone heard of a violin plot? Yeah. Do you like them or do you not like them? I've gotten really mixed receptions with violin plots. Some people, I mean, it's just, I don't know. I think it's just it's a little too something for some people. But I like them. I use them a lot, but like I do have to explain them. But the main thing is that like I think all of these visualizations are really helpful, but sometimes you may have to kind of talk people through it because they have not seen something like this before. So that's something that can you want to consider when you're kind of presenting. So thanks, Sarah.
Thank you.
Okay, let's see. Stephanie, are you ready?
Yeah, I can go.
Okay, great.
Let's see. Okay, can you see my screen?
Yep.
I feel bad following after Sarah because hers was so pretty, and I made 0 attempts to make mine pretty. So apologies for how mundane it is. And I'm doing also a very simple one. So this is factor in in the FORCATS package, and it is used to reorder factors by frequency in the data. So I loaded up the penguins data set, and then I had to turn them into a factor variable instead of, or a factor instead of a character vector. And then I made sure I did it right. And then you can see just regularly when you do it in a table, they come in the order that they appear in the data. So you have the Adelie 152, the Chinstrap 68, and the Gentoo 124. So if you want to use this to reorder them, you can then get them in ascending order, or descending order, I guess, sorry. So you can see them here in order. This then can be, you can also embed this within ggplot, which is probably like the most helpful thing. So you can see here's the ggplot just as it is, without ordering them by frequency, and then it just presents a lot more logically when you insert the factor and freak in the ggplot. So is it helpful? Yes. It's a very practical tool for being able to look at and present your data in a logical fashion. It's probably the most useful when there are a larger number of factors, but more than 3, but it was a good example to look at a small number, and I think I will use it frequently.
Great. Thank you so much, Stephanie. Any questions for Stephanie? Yeah, I will say FCT and Freak is, and that's the one like with FCT reorder. Those are some of the 2 most useful functions in the 4cats package. And I swear this is like something it keeps everyone up at night. Like, how do I change the order of my bars by size? I'm sure you, like, at some point in your career, you've tried to Google this. So now you know how to do it. Okay. Oh yeah. So Bradley was asking Sarah about the PowerPoint. Just want to point that out. She answered that question in chat, that there is actually a knit option to PowerPoint. It's not 100% pretty, but it will get you most of the way there. It's not, I don't think it's the #1 priority up at RStudio, but it is kind of available. I'm just going to write a quick message. Okay, so let's see who's next on the list. Clara, are you ready to present?
Yep, I'm ready.
Okay, great.
Share my screen. Okay. Is that working?
Yeah.
So my function was crossing. And so I decided to use the Star Wars data set, which was actually really cool to look at. If I ended up spending more time looking at the Star Wars data set than this function. But there's like this website and they have a ton of more stuff on GitHub and like everything about Star Wars for future projects if anyone's interested. But my function was crossing, which determines what if you have factor variables, which ones are represented with each ones. So I used the Star Wars data set and looked at the homeworld and species. So to see what species, and this is the data set is only about 85 rows. So it's like more of the major characters, and it goes through Force Awakens. It doesn't have the last 2 movies or any of the additional ones. So looking at this, like I decided to look at the species that inhabit Tatooine random. And so from this, it showed that droids and humans are on Tatooine, and that's their home planet. And I was kind of curious looking at this. So it makes it really easy to look at if you're trying to see what species are inhabiting a planet, because that's super relevant in work. And it's alphabetized, so it's easy to find what you're searching for. I also wanted to look at it since I know that there are also Jawas and Tusken Raiders on Tatooine, and there's also a prominent Hutt population where those lie on here, and they're not here. You do see the Hutts considered Nal Hutta their home planet, even though a lot of them live on Tatooine. And so that's kind of interesting to be able to search for it and see what's represented. My last example, I decided to just look at gender and skin color by species. And because I'm not entirely sure what other species their gender or skin color breakdown was, I was mostly looking at human. And so it is interesting, you can like very clearly see that there are the only female humans in Star Wars that are prominent are considered fair or light-skinned. And males have like dark, fair, light, pale, tan, and white. But there's a lot of like different ways that they're basically saying white here. And then they're just saying dark, which is interesting. And so I think that this, going down here, this function can be very useful. It could show you a lot of basis of your data, and like you can see what goes with what, or like when you're looking at the penguins data set, like what species live on which island. But I think the downside of it is that you don't have numerical values. So if you're trying to look at like statistical methods, I think like the group by and summarize combination is still ideal. And so I think that this is mostly limited to like just initial analysis and determining if something is in a data set rather than any like long-term consequences of that. And so I looked at this with the counts. It makes it a lot more relevant than with just the crossing function. So that's it.
Great. Thank you so much, Claire. Yeah, I will say that crossing is really useful when you're trying to identify what are called structural zeros in your data. So the most common example of a structural zero is males and pregnancy. So, you know, until the world changes, men cannot, for the most part, cannot be pregnant. Trying to be respectful to trans people here. So, but so yeah, that's so like using a function like crossing can kind of make you aware of what kind of combinations exist in your data set. So just a comment from Stephanie. So she said, you can tell you had a good time on this one, Claire. I'm glad you had a lot of fun doing it. And then a question from Brady, where did you find the Star Wars data set?
Yeah, I found it in a package. I'll link the package. Part of it is downloaded in R, and I think the rest is available through, is in Python, or you can download it on GitHub and upload it to R.
Great, thank you. So let's thank Claire. Sorry, we should be thanking everyone because everyone's doing such a great job in teaching us. So the last one we have is Martin. So Martin, are you ready to go?
Yep. Let me just figure out which one's the one I'm actually trying to share here. It's this guy. Are y'all seeing the function of the week?
Yep.
Cool. All right. So I had floor date, which is in the package lubridate, which I thought was part of the tidyverse, but wouldn't run with just tidyverse loaded. And basically what floor date does is it rounds off date or time like objects in order to create a sort of maximum level of specificity. So let's say we have this value that's a date that's like today at 3:15 and 21 seconds. And let's say I really only care about what day it is. I can use floor date and specify the object and specify that I want to do days, and it will return just the date and get rid of all the other time stuff. So it essentially makes your data less specific. in regards to date and time objects. And you can do this also for a data set. So with the penguins data set, they had, I think a couple of them were time values. The date egg, I believe, was the day that either the egg was like laid or hatched. And if I just want to know the years, then it'll turn all the day and month things to just 1 and 1 and just tell me the year values as far as specificity there. As far as how helpful it is, I think that there are other functions in the lubridate package that I think do this better, because if I'm just looking for years, I don't really want to like have this 0101 stuck on it. And as far as I can tell with ForDate, you can't do that.
Mm-hmm.
It's definitely good if you want to know a date and you don't want to know the time, but it's recorded with time values as well. I think that's probably where it's the most useful. But I know that lubridate has just like a years and day function where it will just tell you what day it was or just tell you what year it was, that I think is a bit more useful for what I would imagine doing with this data set, or not with this function. Yeah, that's about it. It's pretty simple.
Thanks, Martin. Does anyone have any questions for Martin? Yeah, I will say that I can't think of a really good use for this right offhand. This was a function that was suggested by the larger group of our users as something useful. So, but lubridate, just so you know, has all sorts of functions for extracting things like the year. So there is literally a year function, so you can put a date into it and it will just return the year. I think there's a month and day function, and that can be really helpful, like especially if you just need the year of something and not the month. But yeah, anyways, great job, Martin.
I do want to add something that I learned from this that was pretty interesting is how to create a date or time object with the as POSIX CT function.
Yep.
I think that one's pretty cool.
Yeah. And dates are, like, I think I mentioned this before, are their kind of own headache. And it's just they can be really kind of hard to work with. And especially when you're doing things like you're trying to count like number of business days and like there are holidays in your time interval. So lubridate does have functions that kind of let you kind of count that. So it's not immediately, it doesn't appear immediately useful, but when you need it, you really need it. So anyway, so thanks everyone for presenting. Great job. So why don't we take a 5-minute break right now, and then we will get into stats. So let's come back at 3:55. If you have any questions for me, just put them in chat. I'm happy to recording. So welcome to, like I said, welcome to part 8. So today we're going to be focusing on building statistical models and doing more Purrr. So let's talk about the learning objectives. So we're going to learn a basic analysis workflow for statistical modeling. So this is going to be familiar to a lot of you, but we'll just kind of go through it. Well, we're going to learn about formula notation, and how to specify models using them. We'll do a t-test and we'll apply it to a data set. We're going to learn and apply linear regression models. So once we do that, we're going to dive back into Purrr a little bit, and I'm going to show you kind of the next level of Purrr, which is to use the nest function and to create what are called list columns. I didn't show you this last time because I try not to blow your mind in a row too many times. But once you kind of learn the basic Purrr pattern, learning list columns becomes easier. So we're going to learn how to use map and the mutate statement on a list column to run a model. We're going to be using these two functions from the broom package, glance and tidy. And we're going to be, glance gives you kind of some metrics on your model, such as R and R squared, whereas tidy gives you kind of the actual terms associated with your model. If there's time, we'll apply an analysis of variance. And if there's even more time, there are a lot of other modeling techniques below, and we can cover them, and like we can figure out what everybody wants to do. Okay, so I'm just going to run the setup chunk. This is just our function run model. And it runs LM on our data frame, and we're just modeling bill length as a function of bill depth here. I'm just going to load it up. We're not going to be using it for a while. So this is where I freely admit that I am not a statistician. I do not have a statistics degree. So this isn't really meant to be a comprehensive course in statistics. We want to show you the basic techniques on running models, but you will need to dig further. My friend Danielle Navarro, she has a great course called Learning Statistics with R. So there's a lot of really great stuff in here. It doesn't use a lot of the tidymodels stuff, but you can adapt a lot of the material from there in your work. So I've been mentioning this set of packages for a while called tidymodels. So it is kind of a parallel set of packages. Oh, it's not really parallel. It's another set of packages kind of analogous to the tidyverse, but it's really focusing on statistical modeling and machine learning. One of its really big successes was the ability. So as you will work with multiple modeling packages, you'll notice that the outputs of these modeling packages are very different. So one of the big successes with tidymodels was this package called broom. And broom mostly works with the output of models. So this is basically going to be a fitted model. And like I just said, sometimes it can be just as difficult to get a p-value out of a model as it is to run it. So broom simplifies this a lot. In the package, there are three main functions. So there is tidy. So this is usually what you want. This gives you the coefficients and p-values associated with the coefficients. When we get to linear models, this will become more apparent. There's glance. So these are measures on your model. So these are measures of fit, such as R squared, log likelihood, and the Aikake information criterion and the Bayesian information criterion. I can't believe I remembered those those abbreviations. And then there's augment. So augment will basically, this will become more apparent what you do with augment. But basically, you can use your model with the dependent variables to make predictions. So the most clear thing I can think of is if you're fitting a linear model and you wanted to kind of assess the predictive fit of the model, you could generate the values of your dependent variable that you're modeling and see kind of deviations. So you could basically calculate residuals using augment. Okay, so before we get started, I have to talk about this data set. Props to Aaron Coiner, who came up with the majority of this notebook. But just talking about the data set. So basically, this is a data set that was trying to measure body composition. So things like percent fat, percent skin, percent muscle. So there were three different techniques. And so these are the definitions in the data set. So The first one is this dual energy X-ray absorptometry technique. And this is actually our gold standard. This is like the most accurate of all these measurement techniques, but it is, because you have to use an X-ray, it is very invasive. So part of the reason they did this study was to see whether they could use these other two methods of measuring body composition, skin fold thickness. So like pinching, basically doing a pinch and like kind of measuring like how thick the pinch is, or this technique called bioelectric resistance. So you can pass a current, low voltage, low watt, just, you know, less powerful current through someone, and you can measure how much resistance they have. Like, so they're literally kind of acting like a resistor. So you're measuring kind of the input, and you're measuring the output. Like, so there, you know, the first one, they'd hold one of the electrodes, and then they hold the other electrode, and like the difference in, this is where my electronics is very bad, but basically I believe it's the difference in voltage is going to, you can calculate the resistance of a person. Just more information about the study. Subjects were children between 4 and 10 years old. Data was collected on 98 subjects. So they tried to be as balanced as possible, 49 males and 49 females. So I just mentioned this, the one of the purposes of the study. One other thing, we want to see if our gold standard, if these body composition levels are different between males and females. Let me get chat up just in case there's any. Just a second. Okay, I got it. Okay, so let's get set up. These are the packages that we'll need. We'll need read Excel in a little bit, but for right now, we're just going to be using read CSV. So let's load up the packages. And again, this is one thing just to emphasize it, like your code chunk. So if you don't want to see the message that read CSV gives you, you can actually turn it off with message is equal to false in your code chunk. Again, like sometimes when you're trying to produce a more polished report, that can be really helpful. So we're going to read this data set called body underscore composition. It's in our data folder. And again, we specified our NA here. We're going to clean the names with janitor. And then we are going to make sure that our gender column is a factor here. So you can see the three columns corresponding to 3 different measurements, and and we have an additional column that measures the gender of the person who was measured. Any questions about this data set so far? Okay. So now I'm on around line 103 where it says exploratory data analysis. So Aaron is going to take a look at we're just going to do. Of course, you should always do exploratory data analysis on your data. That was the only thing I took points off for on the exam, was if you didn't kind of do some exploratory visualization, because it is really important, or comment on like the skim output or the glimpse output. Okay, so we are going to so here we're going to basically do a pivot longer. So we're going to take these 3 columns and we're going to collapse them into our 2 columns. So the column that has the column name is going to be called method, And the values are going to become another column called body fat percentage. So the reason we do this is that, again, it makes things, using pivot longer to make this kind of long format data set helps us in our plotting. So now you can see, so each line of our data set actually corresponds to 3 lines now. So each 3 row 1 patient. And you can see that these are the different measurement methods, and these are the body fat percentages that resulted from that. So, so now we're going to take that long version of our data set, and we are going to do a box plot of body fat percentage versus the different kinds of methods. And, thank you to Sarah for talking about geom jitter. So you can see that we have used geom jitter here to kind of overlay on top of our box plot. And so it gives you, again, it gives you an idea of kind of the distribution of values. Just kind of looking over this, do you think there are differences in the medians of each method? Yeah, so Colin says yes. Anyone else have an opinion? So it is hard. It's kind of like, let's go back to kind of thinking about this. So remember, like the DXA is our gold standard method. And then BR is our body resistance, and then ST is skin fold thickness. So I don't want to say that was a loaded question, but it really, I guess to answer that, it really depends on how accurate your measurement needs to be. My guess is that skin fold thickness seems to correlate, or is going to be highly more correlated to DXA than the body resistance method is. But that's just to kind of get an idea of what's going on with the data. So as Aaron mentioned, so it appears the measurements are close to one another, but there are some noticeable differences. So the very first thing that you might think of to do in terms of statistics is a t-test. So we are going to be testing the mean between 2 groups, whether the mean between 2 groups are similar given their standard deviations. And just to like confirm that the measurements have to be numeric because there are other tests for categorical data. So, and I apologize if this is like really kind of beating a dead horse, but I do try to when I teach statistical methods, I do very carefully try to use. So the null hypothesis for a t-test is that the 2 means are equal, and the alternative hypothesis is that they are not. So this is just a little bit of commentary that Aaron was talking about. So one purpose of the study was to determine whether there was a difference between all of the different. So we're going to use a paired. So again, so we're going, this was kind of our very general hypothesis. So we need to actually, need to make it specific when we are doing our statistics. So technically this first one should be alternative hypothesis. So, and this is, I tend to think the opposite way that most statisticians do, in that I try to think of what the alternative hypothesis is first. And then I kind of use that to help me define the null hypothesis. So our alternative hypothesis here is that there is a difference in mean fat mass measurements between DXA and our skin fold thickness method. And the null hypothesis is that there is no difference in the fat mass measurements between the two methods. I think this should be fat percentage. So we're going to set our significance threshold setting in alpha. So this is kind of the first, I guess I'll just ask this question now. How many of you have done a t-test in R? Yes, I'm guessing most of you have done it, so too many. So I don't want to kind of, you know, do this, put this into the ground too much. But one of the ways you can do a t-test is you can basically put the two columns or two variables you want to compare. And we're going to use a paired t-test because, again, there are duplicate measurements between our variables. Or yeah, so because remember, each of our patients in our study has 3 measurements. So this, you're probably familiar with most of this, but the one thing we're going to do is we're going to pipe it into our broom tidy. So we're going to assign this into tidy output. So let's take a look at tidy output. Again, the reason why I really like tidy is that it's really pretty easy to kind of access like the different parameters that you need from our model fit. So that was the first way of doing t-tests. So the second one we can do so that was letting us kind of use the outcome and grouping variable. But the one that you may be kind of somewhat familiar with is this what's called the formula notation or the tilde notation. So we can specify, and again, like the format of the function is usually, so our outcome variable is going to be on the left, and then our dependent variables are going to be on the right. And again, the tilde kind of takes place of the equal sign. So in to do this t-test, we have to use the long data. And we need to filter it to only have our DXA and ST methods. And then we are going to do a t-test using this this tilde notation. So our outcome that we want to predict is body fat percentage, and we're going to use the dependent variable of method here. And here again, this is where you specify the you can specify the data set so it knows what you're talking about, and then we'll pipe it into tidy. And so hopefully these things are identical and they appear to be. So that is kind of the first way of, those are 2 ways of running the t-test. So let's kind of review it. So the first one, we used the wide data. So we directly put in our columns into here. So you can see we're using the $sign notation to get to put in our variables directly. The second one, we used the long data, and we used the formula notation of method to specify our dependent variable was method, And our outcome variable that we want to predict is body fat percentage. Are there any questions about this? Because I know tilde notation can be really confusing.
I have a question about the predictor and the dependent variable.
Yeah.
So method is the dependent variable, right?
Mm-hmm.
And the body fat percentage would be the outcome, right?
Exactly.
Okay,
So let's take a look at the data set. And so you can see that currently method has all three, but when we're doing a t-test, we only want to compare two of them. So you will have a chance to practice this and test your understanding. So just a second, let me get back down here. Okay, so now we're on line around 175, your turn. So what I want you to do is run t-tests, but I want you to compare DXA and BR instead of DXA and ST. And when you're ready, paste your code into chat. Okay, let's see. Looks good, Brady. Looks good, Amy. Looks good, Lindsay. So yeah, the main thing we're doing here is we're just filtering down to the two methods. So yeah, it looks good, everyone. Looks good, Casey. Looks good, Natalie. So I'm just going to fill it out. Say BR. So if we run this again, so at an alpha of 0.05 is the difference between means is the difference between means significant? I think I phrased that wrong. So just look at the output. Yeah. So our p-value is less than the alpha that we set. And you can see this is the estimate is the estimate of the difference. So we notice overall there is a difference between means of 0.85 in terms of percents, in terms of body fat. So the short answer is that skin fold thickness seems to be better here than body resistance. And I'm sure, you know, everyone likes body resistance because it's more kind of technologically cool, but sometimes the old ways are best. Yes, exactly, Jessica. So now we can ask some questions about correlation between measurements. So I'm going to show you this. So this is a function called ggpairs, and it is in the ggally package. I think that's how you pronounce it. It might be ggally, but I'm pretty sure it's ggally. So what we're going to do is we're going to look at body comp, and we are going to provide it with the aesthetic of color equals gender. And so remember, there's only 4 columns in body comp. So it is going to it's going to make correlation and distribution plots for all of the pairs between those three, except for gender. And so you can see overall, so we can see the kind of the overall correlations. So we've got, these are the methods. So DXA is here and here. Obviously, correlating with yourself is you're going to have a score of 1. But you can read this. So this is, you can see these are kind of comparing across gender. And you can see kind of the overall correlations between this. So this is the DXA versus BR. This doesn't tell you as much as you might hope, but I mean, it can be a useful way of assessing correlations between variables. I will say that a lot of the times when you're building linear models or even logistic models, I mean, you really have to think about multicollinearity. So this is a really good tool to kind of assess that, whether that exists between variables in your data set. I use this all the time because it does help me build better models. Yeah, so this is when someone showed me this package, I was like, this is really great because it really gives you it's very clear about what's going on, and you can even, I really like that you can color it by a factor, which can be even more insightful. So that was our that's just our pairs plot. So we can use we can generate a scatter plot with a trend line, and we learned this. We can use geom smooth. So we're going to put DXA on our x-axis and ST on our y-axis. We'll use geom point and then geom smooth to plot the trend line. So between DXA and ST, do you think it's pretty highly correlated? Yeah, I would say so. I come from physical sciences, like physical chemistry, and we have a joke that in physical chemistry it's only highly correlated if it's 0.95, whereas in social sciences a correlation of 0.1 can be considered important. I try not to rag on social scientists too much because humans are much more difficult than atoms and molecules to deal with. So I freely admit that. So no slight against social scientists. Humans are very hard to predict. But I would say that these are reasonably, these two measurements are reasonably well correlated. Think this is just, so I just want you to try running this code, and so we set SE is equal to true. Just let me know what it adds to the graph. Yeah, exactly. It adds a confidence interval. And you can see we have much fewer measurements out here. And so our confidence band is much wider compared to we've got a ton of measurements over here. I guess there's a lot of kids who have very low fat percentages overall. So you can see that because we have so many measurements over here, our confidence band is much narrower. So let's get into making a linear model. So we've established there is a correlation between our DXA method and our skin fold thickness method. So one thought is, can we actually build a linear model using how predict and show like how we can use skin thickness to predict the actual DXA body fat percentage value. So, and again, so this is kind of our linear model. And so X is our dependent variable and Y is our independent variable. And we've got these two terms in our model. So we've got our intercept, which is B, and we've got our whatever that term is. So that's the scaling factor for X. So again, so like translating this over into R's, so we want to use DXA, ST to predict DXA. So we want the thing we want to predict is on the left always, our outcome. And our independent variable is going to be on the right. So if we wanted to use both ST and BR as predictors in this model, does anyone know how we would specify it? Yeah, exactly right, Amanda. So you can add the second term with a plus. So you could put BR on this side. So now let's build our linear model and let's pipe it into tidy. So again, we're using skin thickness to predict DXA. And just looking at the ST term, is a p-value, like if say we establish our alpha of 0.05, is our p-value significant? Yes, it's much smaller than our alpha of 0.05. So just to kind of translate it back to the original equation, if we're using a skin thickness, so our intercept is going to be, and I think Aaron, 0.29. So this is the intercept, and this is the this is the A term. So it's 0.93 times the ST value. So let's do this. So remember, we have that gender variable in our model, which is a factor. But that's the nice thing about linear models, is that factors can be used as inputs. So we're just going to add that to our original model by just using the plus sign and gender. And we'll pipe that into tidy. Come on. Is this working for everyone? I'm going to do the try and cutting paste again. Okay, I may have to restart this, so I'm just going to relaunch. Are there any questions while I relaunch? And like I said, a lot of this is review, but part of the point is really to get you familiar with the formula. I said it again, formula notation. So just give me a second. I'm just going to relaunch things. I think I have to load up a couple of the code windows, code chunks. So bear with me. Okay, so we're back. So you can see that we've got our ST variable, but our categorical variable got converted into what's called a dummy variable. And this is understanding this was like, it took me a long time to really understand dummy variables. But the way to read this means that this is coded as, this is what I don't like about dummy variables, is that if the value is equal to 0, then the dummy variable is coded as 1. If it is not equal to 0, then it is coded as 0. Yeah, so dummy variables are very confusing. So that the point really here is that your interpretation of your model is dependent on how you set your dummy variable up. And so let's look at this. So what we're saying is, if our gender is 0, I can never remember exactly that. Oh, from going from a gender of 1 to a gender of 0, there is a difference of 0.577 in body fat percentage. So that, and this is just Jessica like emphasizing this. So it's coding gender equals 0 as 1 here, and 0 if gender is 1. This is a nice web page about dummy variables. I will say, it took like, this is one thing that it's really important to be very clear about, especially when you're going to try to imagine communicating this result to, like, say, you were at a gym and they were trying to decide, well, whether they should use skin thickness or the new body resistance. So like, how do you communicate that difference in genders? So again, making sure that your coding kind of matches your interpretation is very important. So Natalie, so for some reason my output gives a value, That is interesting. I cannot answer that question right now. I don't know what's going on, because this should be the same. Are the estimates different for the other two terms?
Yeah, it was doing that earlier also, like the code block around 252.
Yeah.
I had
That is
0.275.
really weird.
For the interception, it says 0.295. So 0.295 is what I'm
I will look
getting.
into this, but because this seems to be kind of a weird thing. So Jessica has the same outputs as me. Oh, so you have these. What's going on here? I will think about this, and I will figure it out. This shouldn't be the case. Yeah. Yeah, so I'm not exactly sure what's going on here. I will go back and figure out what's going on because you have the exact same notebook as me. There might be some weird, it might be something like, yeah, so I will try to figure out what's going on here. So just to make things confusing, Sarah has the same result as me. I'm going to look into this. So remember, our gender variable is a factor with levels. So what we can do is, and because of the order, so 1 goes first and 0 goes next. So confusingly, again, these get coded as 0, 1 in our dummy variable, but we can fix that with an FCT relevel. And this will let us basically fix the ordering of our reference group. So we're saying that 0 goes before 1. So now our dummy variable will be the same as the as our expectation. So you can see now we have gender 1. So this is, it's 1 if gender is equal to 1 and 0 is if gender is equal to 0. Any thoughts about why the coefficient changed signs? Yeah, exactly, Jessica, because our reference group changed. So that's why you have to be very careful when you're using dummy variables and they're encoded the way you expect them to be. And I don't have enough time to really go into dummy variables, but this is just something you want to be very careful about when you're including dummy variables in your model, because your interpretation, the way you interpret the dummy variable changes with how it's based on how it's coded. Any questions about that?
I have a question about the intercept.
Okay, so why don't you try your turn? So we're going to add BR as a term in the model, and I want you to compare how it changes the p-value of ST. And again, your values may be slightly different from my values, and I'm still not sure what's going on there. So just tell me in terms of the magnitude of the change. Did it get larger or did it get smaller? Oh, yes. Yeah, it got larger. Okay, thanks for letting me know, Bradley. So Bradley is saying that there's discrepancies. He thinks he didn't load one of the chunks before, so that might be the difference between you and me. I will go back and trace that through the code. There's probably one thing. Oh, yeah, exactly. It's the code that's removing the NAs. So that's probably why everyone's values are slightly different. So getting back to this, we know that ST and BR are correlated. And this is an example of multicollinearity. And when you have variables that are highly correlated with each other, you need to make a decision process because it can actually decrease the p-value of both of the variables that's added in the model. So I will say, has Tuan talked about this in class? Yeah. So Bradley's saying yes. Are people familiar with the term multicollinearity? Yeah, it is a confusing thing with so variance inflation. Yeah. So it is something that you do want to be careful of when you're building models, is being aware of kind of correlations between variables. Yeah. So yeah, so I mean, and part of this is like when you are building a model, you have to get input from your collaborators. Like they may have included both of the variables as measurements, but you need to get a sense of which of the measurements they probably trust more. And there's lots of conversations that you have to have about this. I will say that this is kind of the one thing I do remember from you know, all of my stats, just because it's a problem that can come up really often. So I will just say, just kind of be cautious about adding variables that are correlated with each other. Make a choice of one or the other. And that choice is usually like part of a conversation. I know Tuan will probably say something else, so I don't want to contradict her. So that's all I will say. Okay, so we're going to end with some more stuff about Purrr. Are people interested in seeing the analysis of variance, or are you familiar with that? Okay. Okay, so we will end with analysis of variance. But I just want to kind of revisit some things. So I was talking about this on Twitter with a bunch of people, and so this is the one case in which using the non-tidy function is actually a little easier. It's a little easier than the tidy function. So remember, we were using split groups to split our data frame into a list of data frames. So there is a command in base R that is called split, and it takes the argument of the data frame and the variable that you want to split on. And the reason why this is better is because it outputs a named list. You don't have to go through all of the rigmarole we'd had to do with group keys or group keys. So if you look at names of penguins by species, you can see they're automatically named. So this is kind of the one area, like and there's been a lot of discussion about split groups because it is a brand new function. I think in this case, split is a little easier to use compared to split groups. Okay, so this is where we get really inception-y. We're going to be talking about list columns. So there is the idea of a nested tibble. And what it is, and we'll look at it as in a second. So we're going to do penguins. We're going to group by species. And we pipe it into our nest function. And let's look at the structure of that. So you can see there are 3 rows for each of our 3 species. And now there is a column called data. And you'll notice that the data contains a tibble. And when someone showed me this, I was like, no, please don't show me this because this is super confusing. But this column contains a whole data frame. So if we wanted to get the first value, we can use, again, we can use our $ notation. So we want to access a column using $data, and we want the first value. Oh, actually, I think we actually want to use the double brackets. Change that to double brackets here. Sorry. And so now you can see that in each of the rows, we have the like each of the rows contains a data frame. Is this blowing anybody's mind? It blew my mind when I first saw it. Yeah, it's, I was like, when I first saw this, I was like, why are we doing this? This is like so weird, but hopefully I will convince you why it's important to do this in a second. So we see that the column is each row of the data column contains a data frame. The important thing to do is to check the class. So what is the class of the data column? You'll see it's a list. So because it's a list, we can use map on it. So everyone get with me so far? Or do you want me to go over it? Like, because I am happy to go over it because this is really super confusing. Yeah, as we kind of work with it, it'll become more apparent what's going on. So so like I mentioned, so the data column is a list. So we can basically use run model on it, and we can output a list. Basically doing this linear model, and you can see that we've got three different model fits. So you'd be like, well, why did you put that in why did you go through this? So this is why. You can take a nested tibble, and you can use mutate. And for each of those data frames in the data column, you can use per map. And because the column is called data, we can apply the run model function to this. So I'm going to show you this. So we now have a column that contains data. We now have a model that was built on each of the data frames that was in that column. And the major reason why you want to do this is that it keeps everything together. And so this is like, instead of having lots of variable names, everything kind of lives in the same data frame. Any questions about this so far? Because this is super confusing. Yeah, so Bradley, so we can look at the individual data frames. So if you go up here, I show an example. So you can look at penguins nested, and then you use the $ data column, and then you can access each of the elements with that. Did that answer your question? Okay. This is, when I first saw this, I was like, what weird voodoo is this? Like, what is the point of this? So let's just review. So we created what's called a nested tibble. And each row of the nested tibble is our groups of interest. And our data is divided by a group of interest in each row in our data column. So we've got a data frame here. This column, each of these contains a model fit that was run on the particular row in the data column. So this is a good time to ask questions if you're confused, or if you want me to go over it again. It will be confusing, but the homework hopefully will clarify a lot of things. So we talked about tidy and glance. So if we wanted to we wanted to basically use glance on our first model, we can use again, we can use the $ accessor to access the column. And then we want the first value of the column. We need to use the double brackets here. And this gives us metrics on our model. So you can see there's an R², an adjusted R². So you can, and our degrees of freedom. So this is a very useful function, especially when you're building linear models. So you can understand you're building kind of, you're kind of checking, you're going up the hierarchy and adding more and more variables. So this can be very helpful to you. So what if we wanted to do that glance on all of the models? So again, we're going to use map. And the column that are the list that we're working on is the model column or list column. And we're going to apply our function, our glance function to each of the elements in the list. And we're going to use this glance. It's going to be, we're going to call that new column called glanced output. So I'm going to run this part before I talk about the unnest in a second. So this, so the glanced output, this is a tibble. It's a single row that corresponds to this row. So you can see that this is a 1×12. And I'm sorry if I've been interchanging tibble and data frame. Technically, everything we work with in the tidyverse is called a tibble. And if you want me to explain the difference between a tibble and a data frame, I'm totally happy to. For the most part, they are very, you can use them interchangeably. But so you can see we created a new column called glanced output. But what we want is actually, we want this to basically, we want this, this single row of our, that comes out of glance. We want these to be additional columns in our data, in our data set. So we want each of the rows to have like an R² column, an adjusted R² column. That correspond to each of the models. So that's where you use this function called unnest. And what this will do is it will basically transform the single row tibble here, and it will add it as columns into our data frame. So let's take a look at that. So now you can see we've got our species, we've got our data, we've got our model, and it unnested. So it basically added it as a data frame. So we now have all of our metrics on our model. And don't worry, you will have an opportunity to practice this in the homework. So any questions about this? Does this seem useful or does this not seem useful?
I was going to type this out, but it's going to take too long, so I'll just say. I'm like looking at how that has the different, like the
I will
model.
say just this, it took me a while to kind of understand what unnest is doing. So just kind of look at this. So again, like compare like this version of the data frame with the unnest. And you'll start to kind of understand what's going on. So let's take a 5-minute break right now. So let's take a quick break and kind of stretch your brains and your bodies. And let's come back at 5:02. And oftentimes, you know, I will come up with questions after I kind of am confused. So I'm going to pause recording. Remember, it has 3 rows and a column. So we added an extra column by using glance, called glance output. So now we have 4 columns. How many columns does the output of glance have? So it should be right here. Yeah, so this has 12. So what we're doing is when we're doing an unnest, we're getting rid of that glanced output column, and we're substituting it. So that leaves us with 3 columns. But because our glance method returns 12, we're going to add 12 columns to each of the rows. So in the end, we've got, actually it's because I added the annotation. So it should be 3 by 15. That should be the dimensions of the new output. So how are people feeling? Okay. Yeah, again, like when I first encountered this, I found this really confusing. But then I started to become very convinced. This lets you run a lot of models at once and over subgroups. And it's extremely powerful that way. So I have a R markdown, which I did for the Tidy Tuesday crop yields data set, in which I literally built a model of crop production for each of the countries in there. And that was something like 200 models, and using this kind of methodology. And so you can see how powerful this using kind of this method is. And I'll have that available next time. So this was the tidy version. So again, I'm going to just run this part just a second. I'll just call it PM. And then if we look at PM dash tidy output, and we just want to look at one of them. So what is the dimensions of tidy output? Do people see that? So I'm just talking about this one here. 2 by 5. Does everyone see that? Yeah, okay, good. So we have 3 columns in Penguin models. We add one temporarily as tidy output, but we get rid of it. So for each row, how many columns are we adding? What is going to be the final dimension of when we unnest? So is it going to be 8 columns total, or is it going to be 7? Any thoughts? So we started with 3 columns. Our tibble has 5 columns, so we should have 8 columns in our new data frame, and those extra 5 columns correspond to these columns. But you'll notice that this data frame has 2 rows. So it's got one for the intercept term, and it's got one for the build depth term. So let's see what actually comes out of it. So I'm going to get rid of these 2 lines here. So let's look at, so we've got 8 columns. So what do you notice about the output? We had 3 rows originally in our, yeah, exactly. So we have 6 rows now. And those correspond, so we are repeating models here, but the unnest basically gave us rows for both of the terms for each of the species. So that is a little confusing when you're first encountering it. But you're going to have as many rows as you have terms in your model. Any questions about that? Okay, so we're now around line. So yeah, very good question, Sarah. So without nesting, it will give you the intercept and coefficient of the overall data. And I actually have you do this in the homework. So what I want you to do is try a nest. So we're just combining the two code chunks here. We're going to apply both glance and tidy. So I want you to try unnesting on both glanced output and tidy output. And give me the dimensions of the new nested tibble. This would have been so nice for the midterm last week. Yeah, I try to be timely, but you can see how long it took us to get here. So wow, 30 linear models, that's a lot. Okay, so I'm getting 6 by 20, 6 rows, 20 columns. Is that what everyone is getting? Appears to be the case. So you can see we have R squared values. They're repeated because there's only one row for those with glance. But we have all of the information. We have our intercept terms and our build depth term. And one of the things you do have to notice is that there were two columns called p-value. So and there was two columns called statistics. So this R does not like to have duplicate column names. So it's going to kind of append a 1 to it. But you can always fix this with a rename. And sometimes it might be more helpful. So I might call this statistic underscore LM and then p-value underscore LM, just so it's clear that it's coming from the linear model. So any questions about this? And to anticipate a question, you can use this to kind of build multiple models with different terms. I have to remember how to do that. That's not something I do every day. So like, for example, if you're using the ICACE information criteria to decide like among a bunch of different models with different terms in them, you could theoretically do it. I can't tell you how to do that off the top of my head. But so congratulations. This is probably one of the most advanced programming techniques in R. So kudos to you for sticking with this. But you can see how powerful it is. So I have mostly shown you the pattern of running models, but I think of any other good uses for Purrr and map in list columns. I'll try to have more examples next time, but I really just wanted to focus on this particular workflow because I think it's one of the most useful ones for you as statisticians. Okay, so I fell down talking about anonymous functions. So let's go over them again. And again, I don't expect you to write anonymous functions. I just want you to be able to read them and understand what's going on when other people use them. Like I said, I like to use named functions for the most part because it's very transparent of what is going on. A lot of times people will write these kinds of anonymous functions, and they will try to put everything in a single line. And I hate that. It's really hard to read that code. So just talking about the terminology, what really is an anonymous function? Anonymous function just doesn't have a name. We don't assign the function to an object name. It's just by itself. So again, we define a function by using the function, and then we put our arguments, and it's encased in our curly brackets. So you can actually use this in a map statement. So again, we didn't name our function. We're just providing the bare function directly into our map statement. So what this is going to do is, sorry, this should be the same. I changed this. it's going to run the mean function on the bill length column. And this is the hardest thing, is like this X. So oftentimes you will use arguments with only one argument with an anonymous function. This is just you'll see this all the time, function X. And that's just, in this case, it is the input is a data frame. So if we run this map function, we will get a list of single values, and each of the values corresponds to mean bill length of that group. And because we provided the na.rn argument, you can see now it is it's now it actually gives us a number instead of an na. So that's the first part of it. Like, so we can pass functions in that are unnamed into our map statement and use these functions in our map statement. So I liked the way Rebecca Barter talked about this, so I'm going to use her words. So this is like one way to use an anonymous function. And like I said, oftentimes people will try to have everything on a single row. And I hate this. I seriously hate this. This to me is really hard to read, but people do it all the time. So really, when someone gives you something like this, just spend some time kind of unpacking and formatting it so it makes sense to you. That makes sense. So you can basically make there's even more shortcuts that you can use when you're in Purrr. So this is an example in which she's writing a function that just adds 10 to X. So this would be the anonymous function that we use. And then, but you can actually use this notation, and this, I hate this notation with a passion, but again, I think it is important for you to kind of understand it. So notice that we've got this tilde here. The tilde takes the place of our function. And you'll be like, well, where is the argument? So there is what's called an implicit argument, and the argument is always named .x or dot. And this is why I hate this, because it's really, it takes me some time to really understand what the hell is going on here. But people use it. So I think it's important to kind of understand what's going on. So I'm going to show you like how this works. So this is our anonymous function. We're going to apply it to this vector. And remember, we're going to use the map double function, which is going to return a double vector. And so we are going to add 10 to each of these values. So yeah, so you can see 11, 14, 17 compared to 1, 4, and 7. So yeah, thanks, anonymous functions. I hate you. But it is important to know, like when you encounter them, what they're doing. Hopefully that was a little more understandable than last time. I was kind of running out of steam. Any questions about anonymous functions? Okay. How's everyone feeling right now? Are you just too zonked? I mean, we can just go through ANOVA and we can call it a day. Yeah, it has been a long day. So let's go through ANOVA. Should be relatively short, and then we can just call it a day. So there are a bunch of other statistical tests that Jessica added to this. So if there are ones that you want me to cover next time, just go down the document and I can cover them next time. Okay, so in terms of analysis of variance, we're going to use the same formula notation. So we've determined that there isn't a statistical difference between our DXA and our skin thickness using paired t-tests, but we also measured body fat using the bioelectric resistance. So we can, again, we're going to do an ANOVA. So we are going to check whether there are differences in means between all of our groups in the data. So is there a difference between DXA and ST? Is there a difference between DXA and BR, or ST and BR? So we can do that with running the ANOVA function. I'm not going to talk about multiple comparisons because statisticians talk about it much better than I can, but I'm just going to show you how to run an ANOVA. So remember, we're going to be using our body comp long, where our method is a column and our body fat percentage is another column. So again, we're going to use the formula method. So we're going to use method as our dependent variable and our independent variable. Sorry, it has been a long day for me too. And body fat percentage as our dependent variable. So given our analysis of variance, is there a difference between any of the paired methods? And using an alpha of 0.5. Yeah, so our p-value is much larger than 0.135. So we conclude that there is not a significant difference in means among any of the methods. So yeah, so the analysis of variance is the AOV function. So I cannot remember from the top of my head, there are different methods that use different sum of squares, I believe. I will come back, I'll research that and come back to you because that can be very important. But I just don't remember it offhand. But this is kind of the basic function in R. And there are other functions and other packages that can do the different kinds of use the different sum of squares methods. So we don't have to do post hoc tests because remember our ANOVA is, what is it called? It's not called the global test. It's called it's the first test that we do. So since our first test was not significant, we do not reject the null. And so that makes no sense to look at the differences between pairs. So that's it for ANOVA. So what I'll say is just kind of take it easy. Go over the material again and give me feedback if you need help and you want me to review anything else next time. So why don't you all take a break, or we'll end class early and you can kind of unwind.